Okay, so in last class we discussed about that first exercise, means all are related to the standard formulas, and in today's class we discuss about method of integration. In that also just we discuss about only first method. Okay, so generally there are three methods in that. First method is integration by substitution, second one is integration by partial fraction, third one is integrating by parts. So in this class just we discuss about method of integration, means how to find the integral value of the given function by using substitution method. Okay, so this is the first method. So I am writing here method name. So method 1, integration by substitution, means how to find integral value of the given function by using substitution method, right? Suppose, generally I am taking one example here. So question will be coming like this: find the value of integral sine of 2x plus 3 into dx. Generally we know that sine x integral value is minus cos x, sine ax integral value is minus 1 by a into cos ax. But here function is sine of 2x plus 3. Do one thing. The bracket value is then 2x plus 3. Just substitute 2x plus 3 equal to t. Put 2x plus 3 equal to t. Now differentiating with respect to x. And here 2 into derivative of x is 1 and derivative of constant is 0. Right? And the right hand side value is, actual bracket is not required. If you want you can write here, no problem. If you differentiate t with respect to x, we get dt by dx. And this value can be written as 2 into dx equal to dt. But we want only dx value, that can be written as dt divided by 2. But what I am suggesting here, so these steps are not required, these two steps. Directly take the given value and differentiate on both sides. Means how to write that value. So here if we take this and 2 into derivative of x is 1 and derivative of constant is 0 and variable is x, then write here dx, and here variable is t, that is dt. Suppose if it is t square, just write 2t dt. Why? Because derivative of x power n is n into x power n minus 1. So 2 into t power 2 minus 1, variable t means dt. And from this we get 2 into dx equal to dt. Now what is the value of dx? That can be written as dt by 2. So either this method or that method. Which one is easiest for you? You can apply that one. Okay. And how to write this one? Integral. So it is sine 2x plus 3 is equal to t. Dx value is dt by 2. Now 1 by 2 constant right outside. Okay. Then remaining is integral sine t dt. What is the value of integral sine x dx? That is minus cos x. So here it is integral sine t dt. Only variable is different, but formula is same. Then we get minus cos t. Okay. So then how to write this one? 1 by 2. Then minus cos t. Then constant c. And finally substitute t value, that is minus 1 by 2. So cos of, what is the value of t? That is 2x plus 3. Then constant c. That is the answer. And one more example. Suppose the value is integral secant square of 5x minus 4 into dx. Here also we use substitution method, right? Now this bracket value is equal to t. What is that? 5x minus 4 equal to t. Now differentiate on both sides. Then here 5 into 1 minus 0. Variable x means dx, and here it is dt. So now we get 5 into dx equal to dt. Now we want only dx value, that can be written as dt by 5. So how to write this one? Integral, it is secant square t and it is dt divided by 5. Now 1 by 2 constant, right? 1 by 5. Then what is the remaining value? integral secant square t dt, na? What is integral secant square x dx? Tan x. Similarly, integral secant square t dt is tan t. So this can be written as 1 by 5 into tan t, then constant c. And finally substitute t value, that is 1 by 5 tan of 5x minus 4, then constant c. So these are the examples. So by using the substitution method, just we find the value of the given function. Okay, value of the given function means integral value of the given function. Okay. Okay, now see one more example. These are the general examples. After completion of this, we'll discuss the textbook examples also, right? So the integral value of 2x plus 7 whole power 5 into dx. Now bracket value is there, na? That is 2x plus 7 equal to t. Now after differentiation we get 2 into 1 plus 0 into dx equal to dt. Now how to write this value? 2 into dx equal to dt, then dx equal to dt divided by 2. So this can be written as integral t power 5 and dx means dt divided by 2. Now 1 by 2 constant, right? Then what is the remaining value? Integral t power 5 into dt. Now what is integral x power n dx? X power n plus 1 by n plus 1. Now n value is 5, so 1 by 2 into t power 5 plus 1 divided by 5 plus 1, then constant c. And this can be written as 1 by 2 t power 6 by 6 plus c. Now t power 6 means what is the value of t? 2x plus 7, then whole power 6 divided by 2 into 6 is 12, then constant c. And for same value, so this is shortcut method. It's a very simple. Now what is the given value here? 2x plus 7 whole power 5 into dx. Na? Suppose if it is x, then x power 5 means that is the form of integral x power n dx, right? Use same formula for this. Then same formula means now it is not required. Na? Don't expand that. If you expand, it takes more time. It is not required. Suppose we have to assume, yes, this is the form of integral x power n dx. So integral x power n dx can be written as x power n plus 1 by n plus 1. But what is the value of x here? 2x plus 7 whole power n plus 1 means 5 plus 1 divided by 5 plus 1. And after using that formula, then we'll take that x coefficient and write in denominator. What is the coefficient of x here? 2, na? Just write 2 here in denominator. Okay. Now constant c. So how much it is? 2x plus 7 whole power 6, right? And 2 into 6 is 12. Then constant c. That is the answer. If it is 1 mark question, directly we can use this method. If it is 2 mark also we use this method only. But in sometimes means those who is correcting that papers, maybe they will be objecting. In that case, we can use the general method. Suppose if it is required for objective, quantitative exam, directly, so without writing on the board, simply we say that answer. Why? Because yes, it is x power n formula. So 2x plus 7 whole power 6 by 2 into 6, 12. Suppose if it is 3x, then 3x plus 7 whole power 6 by 3 into 6. Suppose if it is 10, 10x plus 7 whole power 6 by 10 into 6, 60. Once if you get that idea concept, then problems are very easy. Clear? Okay, now this is example number 5. Integrate the following functions with respect to x. In that 4 sub questions will be given. Okay, now we'll take first question. Integral sin mx dx. We know very well about this formula. This is a form of integral sin ax dx. Na? Integral sin ax dx can be written as minus 1 by a into cos ax. Suppose if you don't know about that formula, then also no problem. just use substitution method. Substitution method means that mx is there, na? So write here mx equal to t. Now m into dx equal to dt. Now dx equal to dt divided by m. So how to write this one? Integral sine mx means t. What is dx? dt divided by m. So 1 by m. Then what is integral sine t dt? That can be written as minus cos t. Then constant. So this can be written as minus 1 by m cos t means what is that? Mx plus constant c. Otherwise directly we write a equal to m, then minus 1 by a into cos ax plus constant. And if you take second question, what is that value? Integral 2x and sine of x square plus 1 into dx. Again we substitute this bracket value is equal to t. What is that bracket value? X square plus 1 equal to t. If you differentiate x square, we get 2x and derivative of 1 is 0. Then variable x means dx and it is dt. Now 2x into dx equal to dt. So how to write this one? Integral. So it is sin t, right? And what is the value of 2x into dx? That is dt. So what is integral sin t dt? Minus cos t. Then constant to c. And finally substitute t value. What is that? X square plus 1. Then constant to c. Now third one. Integral of tan power 4 root x secant square root x divided by root x then into dx. First we substitute root x equal to t and derivative of root x can be written as 1 by 2 root x, right? Into dx equal to dt. And from this we get 1 by root x into dx equal to 2 into dt. So this can be written as tan power 4t and it is secant square t, right? Then 1 by root x into dx means 2 into dt. Now 2 is constant, subtract that value. Then what is the remaining? Tan power 4t secant square t dt. And we know that derivative of tan is secant square, na? Again we use substitution method, right? Again we substitute tan t equal to p. And the derivative of tan t is secant square t dt equal to dp. So this can be written as integral p power 4 into dp, right? And which form it is? Integral x power n dx. Then what is the value of that? X power n plus 1 by n plus 1 plus constant, right? Where x equal to p, n equal to 4. Then how to write it? It is 5, na? So 2 by 5 p power 5 plus constant. Then 2 by 5 into what is p? P value is tan t. P power 5 is tan power 5t plus constant. Again substitute t value, right? So 2 by 5 tan power 5. What is the value of t? That is root x. Then constant c. And fourth question is very simple question. What is the value here? Sin of tan inverse x divided by 1 plus x square into dx, right? And we know very well about the derivative of tan inverse x is 1 by 1 plus x square, correct? Now what is the substitution here? Tan inverse x equal to t. Then derivative of tan inverse x is 1 by 1 plus x square. Variable is x, then dx. That can be written as dt. So how to write this one? Integral. It is sin t, right? 1 by 1 plus x square dx is dt. So what is integral sin x dx? Minus cos x. Similarly, minus cos t. Then constant. And finally substitute t value. What is that? Tan inverse x. Then constant. Now example number 6. Find the following integrals. In that first question is integral sin cube x into cos square x into dx. Integral sin cube x cos square x dx. So how to simplify this? Suppose if you write cos square x equal to 1 minus sin square, it is useless. Useless means in that case also we'll find that solution, but it takes more time. So better. So this is about substitution method. Do one thing. Sin cube x is given, right? That can be written as sin square x into sin x and into cos square x into dx, right? And here this is the formula, sin square x plus cos square x equal to 1. Suppose if you want sin square x, that can be written as 1 minus cos square x. But why we are converting into cos term, means cosine term? For what reason we are converting into that? Suppose if we convert into cosine form and after differentiating we get derivative of cos x is equal to minus sin x, then we get sin x value. Got it my point? Because of that reason only we are converting into that form. So now how to write it? Integral sin square x can be written as 1 minus cos square x, right? And write this cos square x. Okay. Then sin x. Then dx. Now multiply these two terms. What is the first term? 1 into cos square x equal to cos square x. Minus cos square into cos square can be written as cos power 4x, then sin x, then dx. Now cos x equal to t. If cos x equal to t, after differentiating we get minus sin x into dx equal to dt. Now what is the value of sin x into dx? That can be written as minus dt. So this can be written as integral. So it is t square, right? It is t power 4, then minus dt. So that is minus. Now split the term. So integral t square dt is the first value. And the second one is integral t power 4 into dt. What is integral x power n dx? X power n plus 1 by n plus 1. So by using that formula, how to write it? So t cube by 3, right? And here 4 plus 1 by 4 plus 1. Then constant. I am writing direct value. Okay. Now what is the value of t? T is equal to cos x. Then t cube by 3 means how to write it? Do one thing. Multiply with minus. So minus into minus plus, right? So 1 by 5. T power 5 means cos power 5x. Then minus 1 by 3 cos cube x. Then constant to 6. That is the answer. Integral of sin x divided by sin of x plus a into dx. Now do one thing. The denominator bracket value is there, x plus a. Substitute x plus a equal to t. If x plus a equal to t, then x equal to t minus a. So dx equal to dt. So integral sin of x means t minus a, and what is the denominator? Sin t, right? And the dx means dt. Now which form it is? This is sin of a minus b, right? So how to write sin of a minus b? Sin a cos b minus cos a sin b. Otherwise sin of x minus y, sin x cos y minus cos x sin y. So by using that formula, how to write this numerator? Sin t cos a minus cos t sin a divided by sin t into dt. Now separate both the functions. Okay. Now what is the first one? Sin t into cos a divided by sin t minus cos t into sin a. Again denominator value is sin t. Then dt. So here sin t gets cancelled, right? What is the remaining value? Cos a, but it is constant. So separate that. Then what is the remaining? Integral and dt. And coming to this, sin a is constant. And integral cos t by sin t can be written as cot t. Then dt. So both are direct formulas. This is integral dx. It is integral cot x dx. Integral dx is x. Integral cot x dx log of sin x or log of mod of sin x. Okay. Then how to write this one? Cos A into, it is t, minus sin A. Then that can be written as log of mod of sin t. Then constant c. So cos A, and what is the value of t? T is equal to x plus a. So write here x plus a. So minus sin a into, then log of mod of sin of t means what is that? X plus a, then constant c. So that is the solution. Integral of 1 by 1 plus tan x into dx. So integral 1 by 1 plus tan can be written as sin by cos. So sin x by cos x into dx. Now just take LCM. Then we get cos x in denominator na, right? And 1 into cos x cross multiplication. Cos x plus sin x. Then dx. Okay. And how to write this? Integral cos x by cos x plus sin x into dx. And now what I am doing? Just I am writing like 1 by 2 into 2 cos x by cos x plus sin x. Is it possible? Yes, it is possible. Why? Because if 2 gets cancelled, then we get cos x equal to this value. Okay. After writing this, what we'll do here? Just write 1 by 2 as it is. And split this function. So what is that? 2 cos x can be written as cos x plus cos x, and the denominator is cos x plus sin x, then dx. But problem, in denominator it is in terms of cos and sin, but in numerator it is only in terms of cos. But we want the same denominator form in numerator also. But how to get that form? Very simple. So write 1 by 2 and cos x plus cos x. Suppose if you write plus sin x, why? Because we want cos x plus sin x form, na? But here sin x is extra value. Then write minus sin x. And what is the denominator? That is cos x plus sin x, right? Then into dx. Now split both the terms. 1 by 2 integral of, first one is cos x plus sin x, and denominator is also same, cos plus sin, right? And what is the second term? Cos plus sin is over. Now one more term is cos x minus sin x. Divide by same denominator value, that is cos x plus sin x into dx, right? And here both are gets cancelled. Then what is the remaining? 1 by 2. So integral 1 into dx is dx. Coming to second one, integral cos x minus sin x divided by cos x plus sin x, right? Then dx. Clear? Now what is integral dx? That is x, standard formula, na? So it is x. And for this we use substitution method. The denominator value is there now. What is the denominator value? Cos x plus sin x. So that is equal to t. If cos x plus sin x equal to t, after differentiation we get minus sin x and plus cos x, then dx equal to dt. Clear? Why? Because derivative of cos x is minus sin x, derivative of sin x is cos x. And again, how to write this value? Cos x minus sin x into dx equal to dt. So this is the value, right? So here integral, so whole numerator is equal to dt and denominator is t, and that is the form of integral dx by x, log of mod of x or log of x. Okay. So then how to write that? 1 by 2. So it is x plus log of mod of t, then constant c. Otherwise simply we can write log of t also. Okay. Then 1 by 2, it is x plus log of mod of what is t? T value is equal to cos x plus sin x. Then constant c. That is the final answer.